Fantastic. Thank you. Okay, so today we will have 2 sections, and it is supposed to be shorter than last time. The first section is confusing concepts. The second section is some exercises to strengthen your understanding. Let's start with the confusing concept. All right. So we are going to cover only one thing in confusing concept. That is, when we said a LTI system is causal, equivalently, we say that its impulse response is 0 when n smaller than 0. And we did not discuss it in very details during the lecture. Anyone know the reason behind it?
I mean, it's just kind of like a real world system, right? You can have signals in the future.
Yes, you're right. That is exactly the definition of causality of an LTI system. So we say that the yn does not depend on future input. And the future input here mathematically means hn plus 1, hn plus 2, blah, 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 right? So how can we relate these 2 concepts?
Isn't it through convolution? So if your impulse response is 0 for all negative n, then like using the flip and drag method, like you'd flip h and like drag it across x, but then when you flip h, you get h actually is 0 for all positive, I guess, future x's. So then when you like actually do your convolution, like all the future values are like multiplied by 0, I think.
Wow, got it, Edward. Excellent. Yeah, exactly. So if we split, if we write down the equations for convolution, we'll have to flip the h, right? So let's suppose it is not. Let's suppose it has some support in the negative region. We explain it better with a figure. Suppose we have h of n looks like this. Okay, and when we flip it to get the h of minus k, all right, it is symmetrical. We got this, right? And then minus k, yeah. And then we shift it by n. We'll see that if we want to get, let's say this is x of n, and then we want the h of n minus k overlaps with our x of k, right? So when they have no overlapping, the convolution result is 0. When they have overlapping, like when they are 0 allies, so you notice that when they are 0 allies, this is basically h of 1, 0 minus k. And we'll get y of 0 equals to the sum of k, right? And to explain it, we'll have h0 times 0, no problem with that, as well as h1 times x1. So having a negative part in the original h of n will result your use of a future input to get the output. And this is not causal, right? So in this way, we can go back and say that, oh, our h of n must be 0 when n equals to when n smaller than 0. So thanks for Edward. Does it make sense?
So can you go over the graphs one more time? Just like go through graph plots.
Yeah. So
just regression of them.
Let's make it movable. So this is our flipped impulse response, right? And we can shift it to do the convolution. And when it is shift to this position, 0, 0 aligns, which means we are generating y of 0. And in this case, we are counting the sum of the multiplication of the overlapping x and h. So this is the visual representation of the convolution. And if we have if we have negative part of impulse, it will generate positive part when it is flipped, right? And the positive part will overlap with the future input.
I see.
Yeah. So by sliding it, it is more intuitive. Nice. So from now on, we assume that everybody knows their equivalence, and this will also be used for the exercise. So let's start the exercise part. All right. 1, 2, 3, 4. We have 4 questions today. The first question, we check your understanding about the LTI properties and the Bible stability given a difference equation. Okay, so let's start with problem 1. So I'm writing down a difference equation that describes the LTI system. And we know that y of -1 equals to 0. And my question for everyone is it linear? So it is hard to say that without writing down anything, right? So let's make it more organized. So let's see. What is y of 0?
Would that just be x of 0?
Right, correct. And we can propagate this and get y of 1. I guess it's too easy for you. So I would just write it down to save you some time. And then we write it in terms of input. We don't want to see any y on the right-hand side, right? And continuously, we can summarize the expression of y of n. So it is the summation over something times h of k, and then plus the current input. Okay? And you can see that this is actually a linear combination of your input x, right? So the coefficients here can be seen as a whole. So let's say it is r of r based on n and k, and we can rewrite the equation to be y of n equals to sum from 0 to n this time, because we want to integrate the x and s of n into the summation as well. And the r of r for the x of n term should be 1, right? As long as we define it carefully. And let's see. Let's use a linear assumption to check. When our x of k equals to a times x1 of k, b x2 of k, what will happen to the y? Let's try to do it. So the r of r will remain the same, and x of k split into 2 parts, right? And because the r of r of n and k, it only depends on n and k. It is not related to our input value, not related to x. So split it into 2 parts. A is a constant, so let's put it outside of the sum. Similar for b. All right. So we can see that this is the expression of y, right? So we get a times y1 plus b times y2. So the answer is yes, it is linear. This is how we determine the linearity of based on from the difference equation. All right.
So quick question.
Sure.
I guess 2 questions. First question is, so is there no way to determine linearity from the difference equation itself? Like if you actually, is there any way, like from the original given equation, like is there any way to directly determine linearity?
So if you want to apply the linearity assumption, we are observing the change of y given the change of x, right? So we want to organize it in the format that on the left-hand side, it is y, on the right-hand side, it is x.
Okay, yeah, I see that. Makes sense. And I guess to follow up, so you basically actually solved this difference equation, right? Like you didn't have to use any like homogeneous or particular solution. Like you just kind of expanded it and it became solved. Like, right? Maybe it's because I'm like not I haven't taken differential equations in a while, but like
yeah,
like
you can
in general, like
yes.
how do you know whether you recursively expand to solve, or like you have to like try and find like particular solutions and homogeneous solutions to solve like a difference equation? Like,
great question. So in this case, we can find the rules after we write down y of 0 to y of 2, right? But sometimes the difference equation is more complex than this one. In that case, you cannot observe the rules, and then you cannot write down the expression in this way. So
I see. So it's like I see. That seems familiar.
Yeah, but whatever method you use, we always want to write down the y of n in terms of x of n.
Makes sense. Thank you.
Thanks.
Yeah, so able to get rid of the plus x of n factor.
Sorry?
How you were able to get rid of that plus x of n? You said you absorbed it into the
Oh,
the alpha
I see.
n minus k or n comma k.
So how do we integrate the x of n in the summation here?
Yeah.
So the alpha n k is defined carefully here. So for which letter should I use? So when the k is smaller than so when k is smaller than n, we say that okay, it is half to the n plus 1 minus k. And when k equals to n, we say this is 1. Then they are equivalent, right? Because because the x of n acts like the last term of the new summation. And we know that the coefficient is 1 because there's just a single x of n here with no coefficients there. So let's just define the alpha n of n and k equals to 1 when k equals to n.
Okay, thank you.
Great. So congratulations that we get the conclusion it is linear. And I have a second challenge for you. Is it time invariant? I'll introduce a trick here, but before that, feel free to say how you will solve the problem.
For time invariance, can we use the original equation?
Sure, why not? What is your thinking? So we want to use the original difference equation to test.
Never mind. I prefer to use the, I guess, solved form.
All right.
I think someone said in the chat to apply shift input and output and compare. So I guess you would like change. You can try changing all the n's to like n minus 1, and then
you're right.
Compared to just shifting the x term.
You're right. So the most straightforward method is to like using the definition of time invariance, right? So let's say we make a shift by 1, and then what will happen to this term? Will it change?
Would it stay the same if it's just the input that we're shifting?
Yeah, so things become complicated in this case. From our previous question, we know that the expression of y of n is equal to this, right? It's equal to this. If the input shift, all the x of k will shift as well. Why? Because originally we have x of n like this. After shifting, let's say it is a ramp to make it more intuitive. So after it shift, every xk change, right? Every xk becomes sk shifted by 1. So the yn will also change. So it is kind of an edited accumulator. This is a new term. So because it is accumulating, so after your shift, the y will also change. So I recommend you to use an example to check. Like the simplest I can think of is the impulse input. Let's forget about the difference equation here and just try to find its answer for the impulse input. So impulse input before the shift, delta of n, right? And then let's see, the y of 0 should be 0, right? Because we know y minus 1 is 0, and oh, sorry, anyone corrects me? All right, so y of minus 1 is 0, and x of 0 is 1 because it is delta of n. So we have y of 0 equals to 1, and then we propagate it, right? And after shifting the input, our new x of n becomes sigma n minus 1, which means we get a 1 at n equals to 1. And in this case, let's observe what is the new y of 0. So we still have this, but this time it is 0 here. So it is 0. Let's continue. All right. What should it be? It's 1, right? And similarly, you can compute it in your heart, right? Okay. So you observe that the y2 is not simply a shift from our y, because the original is 1, and then it has half, and then you have 1/4. But now we have 1, and then 1/4, right? This is missing. So back to our equation here, the y of m minus 1 will change accordingly because every x of k is changing. But the 1/2 to the n remains n here. That is what creates a difference. So if you are confused about which one to shift, which one not to shift, you can use the impulse input as your trick to start the problem. And yeah, and then you can go back to the equation to verify it. So that is my suggestion for this kind of problem. Any question?
Wait, so on the first part, you just shifted the output y of n? Is that right? Or
where?
Oh, when you say like y of 0 equals 1, y of 1 is 1/2, y of 2 is 1/2 squared, and so on.
So it is not a simple shifting. We'll see that the y of 1, this term is missing after we shift the input. So it directly jumped from 1 to 1/2 to the 2.
Oh, I see. You're comparing the original function to the shifted one.
Yes.
Okay.
Yes, you're right.
Can we use the impulse example to prove it's not time invariant, since if it doesn't hold for one specific example, it can't be time invariant at all? Or do we have to always use the equation after?
You can use the impulse input because the linear time invariant, the linear system is a weighted summation of its impulse response, right? So the impulse input will produce an impulse response, and that is sufficient to prove it's not time invariant.
Okay, but that's only for that's only for linear systems.
Yes.
Okay,
but
thank you.
Let's say in this way. So because it is a linear system, the time invariance of your impulse response will be sufficient to say that the whole system is time invariant or not. But if you just want to find a counterexample, no matter it is linear or not, as long as you find a counterexample, we can say that it is not time invariant.
Okay, thank you. But it doesn't work to prove it, since you would need to prove for all things.
Yes. So you can use any input to prove that it is not time invariant. But if you want to prove that it is time invariant with just one impulse response, you have to say that it is linear.
Okay, thank you.
Yeah, great.
Sorry, this might be trivial, but in the after shifting input equations, for y2 of 1 and the following y2 of 2, how do those come out to being 1 and 1/2 squared? I'm just trying to find like where you got the inputs.
Could you specify which equation you're talking about?
After shifting input, y2 of 1, how it equals 1. I get that it's 1/2 to the power of 1, and then y of 0, which is 1. I'm missing something. Is x2 of 1 1/2.
Okay, so y of 0 before the shifting, we can write it down in this way. And we know that y of minus 1 is 0, so this term is 0. And then this is 1, so we got y of 0 equals to 0 equals to 1.
Okay, so it's before shifting.
Yes. And after shifting, we notice that the x2 of 0 is 1 because the impulse is shifted to the right by 1 unit.
I see.
Mm-hmm.
Okay, thank you.
Great. Okay, fantastic. And, well, we can play a lot of things on this equation. So the third challenge, is it Bible stable? How can we determine that? So recall the definition of Bible stable. It says, when the input is bounded, we get the output bounded as well. That is to say, we still need to write y of n in terms of x of n, right? And record what we said about y of n. If we write it down in terms of x of n, we get this, right? And then we know that x of n is bounded, so it is smaller than infinity. And how can we apply it to the equation? Okay, so since the input is bounded, that means that its values at every index is finite, right? So we can further write it down as every index, every value in the x of n should be finite, right? And then from this equation, we can write on and we can add the absolute psi at both sides of the equation, and we get y of n equals to absolute value of the whole things on the right hand side, and then it is equal smaller than split it into two terms, right?
Wait, I'm a little confused. Maybe I just didn't recall correctly, but does Bible stability like imply that the sum of the absolute value of xn is less than infinity, or just is Bible stability just saying the absolute value of xn is less than infinity?
I think they means the same because we add the absolute psi to the x of n, right? So
no, but I'm thinking like, for example, like the unit step function, right? The unit step function using the second definition you gave is bounded, but the sum of the unit step function is not bounded, right?
yes.
So like, maybe I just don't remember, but I thought it was just like, I thought the unit step function counted as a bounded input. So I'm thinking, I don't know. I thought it was just like, I thought it was just the second definition, but I don't know.
All right. I think you are right. Yeah, I think you are right. So the definition should be this. Let me check it real quick. Yes, you're right. You're right. So when the x of n, the absolute value is finite, we get a finite output as well. Yes, you're right. Thank you for pointing that out. Okay. And then we continue the inequality. It is smaller than the sum of two absolute parts. And then we can further split this sum as well, like this, right? And then let's write down the concrete expression. So we know that this is always positive. So let's move it out of the absolute value. Good up to now. All right. And we know that this is finite. This is finite as well. So let's say that, so because they are finite, so we can find a number that's large enough to be bigger than them, right? Let's say the number is m. We can represent plus m, right? Cool. And we know that the m plus 1 minus k should be positive, should be non-negative, right? Because we're accumulating like this. So it is decaying, and it times a finite number and plus a finite number. So we can say that y of n is finite as well. Does it make sense? So the conclusion is, it is Bible stable. Yay. So that is the end of question 1. Any problem? Any question?
Just curious, do you know any functions that are not Bible stable?
If it was
Good question.
If it was a whole number raised to an exponent, would it be unstable? Or a number above 1?
So, well, you asked a question that I feel it difficult to answer. So because usually our practical system that we pay attention to are stable. So.
Right. Okay.
Well, I'm a little confused about this. Does this prove that it's Bible stable? Because if it's Bible stable, shouldn't you find like some number like capital N such that for any lowercase n, yn is less than capital M, or sorry, capital N? And then that doesn't exist, right? Because like for a given n, you can say, okay, it's bounded by m, and then that works. But then you can increase n, and then y of n will get successively larger and larger, right? Because like you proved, okay, it's less than infinity, but like n, yeah.
Yeah, I got it. But we can only say that we can find a large enough number when we know that it is finite. So if it itself, it is not finite, we cannot say that we can get a big enough number. So about the counterexample, I think of 1. So we see that there is another component here, right? If it is not 1/2, if it is like 3, n plus 1 minus k, we'll say that it will go to infinity if we continuously increase the n. So it won't be bounded by m because it will explode as we increase the index.
I see. So like this, it's because we have that like geometric series where the ratio is like less than 1. I see.
Yes, you're right. You're right. So about the Bible stability, we want the numbers to be smaller than 1. Otherwise, it will grow exponentially, and which causes instability. Great. Well, it seems that we are running out of time. So, but thank you for having excellent questions. And for the rest questions, I will not cover every computation details, but I will provide you ways to think about it, and you'll find it helpful in your homework. So the problem 2 is, let's say we have z of n, which is a convolution between y, x, and y. And we know that x, the sequence that equals to 0 when n smaller than n1. And we know that yn only has supports between m1 and m2. I have an interval, right? And if we are asked to analyze what the z looks like, we'll surely apply the convolution, right? But there's but what about writing down the expressions in different intervals? And the way of thinking is we usually categorize into 3 types. The first type is no overlap between the x of k and y and minus k. If there is no overlap, the result is 0. The second situation is total overlap. So if one sequence is shorter than the other, we will have the overlap for the shorter one, right? Let's say a sequence is within the interval of another sequence, and in this way we will have a summation over all the index in the shorter sequence. And the third case is partial overlap, which means that the 2 intervals are not fully overlapped, but they are partially overlapped. In this case, we need to be careful about the index and the boundaries. And in this case, we can write down the equation of z in this way: 0 when they have no overlap. But make sure that you know what is the overlap interval. So you should not just say no overlap here. You should say, oh, the n is between which interval? It belongs to which intervals? Maybe it's a union of 2 intervals. Who knows? And then partial overlap. You write down this equation here. Oh, sorry. You write down partial k equation for the partial interval. So similarly, you write the total overlap for the total overlap interval. Okay, so it is different from our previous practice that you generate the concrete values of every for every index, right? So this is like listing down all your results. But sometimes the sequence might have infinite support. So in that way, you cannot exhaustive all the result. So in that way, you need to utilize the expression and put it into 3 categories. Okay, so that is the way of thinking, and I'll put the answer here for you to check. And for partial, for total, great. You'll see a simpler version in your homework, and feel free to ask any question about that on Discord if you feel confused them. And let's go to the problem 3. So problem 3, check your understanding about how to say a combined system. Okay, we have a system here called system 1. All right, and we know that. Okay, we times the beta here, and we know that the x1 is linear time invariant, and we know that its expression in difference equation is for n bigger or equals to 0, and we know that y of -1 is 0. And can you find the impulse response of S1? So we notice that the input to the S1 system consists of 2 components. The first component is x of n. The second component is a delay x of n times beta, right? But we are asked to calculate the impulse response. So for impulse response, the input is an impulse. So we don't need to worry about the x of n here. We just need to worry about Wn. So W of n is impulse, and then we want to get Y of n, right? So this is basically H of n of the system 1. And then similar like how we propagate before with the impulse as the input, we can have this is equal to 0 for our negative indexes. This is because the y of -1 is 0, right? So x1 of n is always 0. And then h1 of 0, let's substitute into this equation and then get 1. And h1 of 1, we have alpha. h1 of 2, we have alpha squared. So it's pretty similar like the previous question. And we can conclude that h1 of n equals to alpha to the n. Because it is 0 for negative, so we add a step function here, right? So that is how we get the impulse response of system 1. We just need to make the input and impulse. And let's say now the whole block is system 2. What should be the impulse response of S2? So it is pretty similar. For S1, we make W of n and impulse. For S2, we make X of n and impulse. So X of n is an impulse now, right? And what is the omega? W. W of n equals to X of n plus beta n minus 1, right? Because X of n is delta, substitute, right? And then because we already know the impulse response of S1 and it is the LTI system, so we can convolute them separately, right? And due to the shifting property of our delta, we will get y of n equals to alpha to the n. This is basically the h of n itself. And then time invariance, right? So it is omega alpha to the n minus 1 and u of n minus 1, right? So we get the impulse response of the whole. Nice. And I would like to ask, is the overall system Bible stable? So I will try to end the discussion quickly. So at the beginning of our discussion, we mentioned that what are equivalent? So LTI causality is equivalent to say the h of n equals to 0 when the n is negative, right? And now it's time to use this property to show the overall system. Why is this step? All right, I copied the wrong question. So is it causal? Sorry, I stayed up too late yesterday and my brain is just not functioning. So because the h of n of the whole system is 0 when n smaller than 0, so the overall system is causal. Great. All right. And in the lecture, we also mentioned that the LTI system is Bible stable if and only if its impulse response, the sum of its impulse response is finite. Okay, and let's go back to the equation to check. This is what? This is the impulse response of the whole system, right? And then we notice that the step function we are familiar with, it just activates the negative part, and the alpha here remain unknown, right? So in order to make the sum of the absolute value of the response summable, which means infinite, which means finite, we need to have our alpha smaller than 1. So you'll notice that the ideas behind the problems are the same. So as long as you understand the concept, you will have solutions in your brain very quickly. So this is the answer. When the alpha absolute value is smaller than 1, it is a Bible stable system. And one last thing about this question is how to express this system in different equation. And I would say that it is simpler than than you may think. So we have the equation here for the S1, and we just need to modify the omega, the W of n in terms of xn, and then we can get the difference equation of the whole system. So the W of n equals to x of n plus a beta x of n minus 1. So our difference equation is great. Okay, we almost finished all our problem set. And one last problem, no need to solve it. It's just a true or false question. Okay, I appreciate your time, so I don't want to make it super long. So question 4, true or false? So let's say I have a parallel of 2 influence impulse response filter. Is it always IIR as well? So let's say we have H1 and H2. We know that H1, H2 are IIR. So are the parallel of them IIR as well? All right. So it is hard to analyze it at once, but we can find, we can think of 2 very similar IIR, right? 2 very similar IIR, and maybe by summing them, we can get summing them or subtraction, we can get a finite impulse response, right? So this is an intuition. And if I give you a concrete example, like f of 1, h of 1 is unit step function, and h2 of n is a delayed unit step function, right? And then, we can determine that it is a positive or a negative sign. So let's say that it is plus h1 and a minus h2, right? They're still in parallel. But in this case, what we get out of the system, out of the parallel system, is equal to un minus 1, which is basically an impulse, right? And an impulse is absolutely not IIR. So the answer to this statement is false. Okay? And one last point in this discussion. Let's determine if this statement is true. I would say a FIR filter is always stable. Is that correct? The FIR filter means that you only have finite numbers of support in your impulse response function for n1, n2, and we know that n1 greater or equal to 0. Okay, so we need to use use this conclusion. We know that for the FIR, this is true, right? So the statement is true, and that's it. Yeah, for the filters, for the IR and FIR filters, we assume that they are LTI system. That's why we use impulse response to represent them. Okay, so that is the end of the discussion too. Feel free to ask any question, stay or leave, whatever.
Okay, thanks, Yo-Yo.
Thanks, Jerry. Oh, so I will stop recording.